Good evening, friends. Today we will discuss Ocr2 and Efr2. When the load current will pass through CT1, CT2 only, then the earth fault relay will never work. When the current setting reach or cross the overcurrent IDMT element setting, then CT1, CT2 current will be same, but Ocr2 will be energized. Ocr2 will be energized. But if any earth fault has been occurred between the 25 kV transformer winding to the CT1 and CT2, in between these two, then the difference current will occur because one part of the current will go to the earth and return to the transformer through the earth, where we at the one leg of the power transformer. Through this way it will return to the source. But the source current will be divided into two parts. One is through CT1 and CT2, and one is before the CT1 earth to the earth to power transformer. At that time, one portion of the two currents will enter the earth fault relay, and if it is more than the setting value, then the circuit breaker will trip. So when the CT1, CT2 return the current, CT1 will supply and CT2 will return to the source, and this current is same. But if current is same and it will not energize the earth fault relay, it may energize the Ocr2 during overload. During overload, it is cross the permissible time. It is IDMT relay, inverse definite minimum time lag. So it will permit the overload. Our transformer, it can carry 200% overload for 5 minutes and 150% overload for 15 minutes. Our setting is 150% of the rated load current. And then time setting, multiplier, plug multiplier setting, time multiplier setting, plug setting, multiplier, all is calculated. All are calculated, and according to this the relay will act. It will permit the overload within permissible time and value, but after that it will trip the relay. This English electric relay, it has disc. The disc is rotating and permitting the time taken to rotate the disc. When the current is more, the disc will rotate fast, and when the current overload but not so much, then it will rotate slowly. And finally, if it cross the settings, then the movable contact will touch the fixed contact, and the DC positive will extended to the circuit breaker trip coil through through master trip relay. But at fault relay, it will energize the inter-tip relay, and from this inter-tip relay, both the circuit breaker 132 kV and 25 kV, both the circuit breaker will trip, because the earth fault is near to the transformer is very dangerous. So Ocr2 will permit the overloading and it will trip the LVCV. But when there is an earth fault, it will trip both the CV through inter-tip relay. This is the old system, English electric system, but this is the basic. It is reflected in the microprocessor numerical relay programming. We are simply giving the CT1, CT2 output to the relay, microprocessor numerical relay, and the programming is there, which we are doing electrically but microprocessor relay, it will do according to the programming and trip the circuit breaker. So one question is there, in 132 kV side the power source is the grid, but in 25 kV side our power source is the secondary of the power transformer. We are taking power from the grid in 132 kV side and giving to overhead conductors from the 25 kV side, and its one leg is earth. This leg is connected to the buried rail and to the railway track. So which current the train will take, it will via the track will return to the source. But if any earth fault in between power transformer 25 kV winding and CT, that earth will connect with the earth, that power transformer one leg is earth, and it will return to the source via this way. So it will a portion of the current through the earth to earth will return to the source. So the earth fault relay will act. But in the 132 side, the earth is taken of the grid. Grid earth phase is 3 phase, grid's power supply is 3 phase, but we are taking 2 phases. And the earth, the neutral earth may be star connection, or if it is delta connection, then earth transformer is used, and any fault in the 132 degree earth fault, it will go connect with the earth of the grid side, But in 25 kV side, it will connect to the earth that we have connected the partners another leg, which is earth, the negative rail or return path, neutral. It is the system. Electricity follows its own circuit. 132 kV circuit will follow its own circuit, and 25 kV circuit will follow its own circuit. The earth fault in the 25 kV never can return to the 132 kV side. It will return to the 25 kV through the earth if there is any earth fault. This is the principle. Electrical circuit always follow its closed circuit. It will not enter the other circuit. Okay. So next we see how it works. Friends, this is the 25 kV circuit. From here we have given the phase through CBN isolators to overhead conductors, and from there pantograph is collecting current and returning to the track, and track to the transformer. As transformer is connected to the track and also with buried rail. So this is the closed circuit. It will follow its own circuit. 27 kV circuit will follow its own circuit, and 132 kV circuit will follow its own circuit. But how? Let's see. Suppose the rated load current 800 ampere is flowing, then how it will pass? You can see that CT1 and CT2 both will carry the 800 amperes. CT1 will give to the OAC, and from loco, wheel and track, this 800 ampere will return to the 25 kV power transformer. Let's see. So we have seen that due to rated load current, the CT1 is carrying the load current, and giving to OHE to wheel to track, and track to transformer through CT2. So CT1 and CT2 is carrying equal current. CT1 and CT2 carrying equal current, but direction is reverse. Direction is reverse. In this situation, from the CT1, the current CT secondary current will flow through the Ocr2 relay, then to CT2, then return to the CT1. But as the current is less than setting value of Ocr2 IDMT, so the circuit breaker will not actuate. So in normal cases, CT1 and CT2 will carry the same amount of current, traction current, and secondary current. So no current will enter into the earth fault relay. So it is clear. Next we will see when overload current will flow. The same thing will happen, but the relay will energize. See. So friends, this overload current we have seen following the same way, just like rated load current. Both CT1 and CT2 is carrying same current, same overload current, but in reverse direction. One is giving to OHE and one is returning to the transformer. But the CT1 and CT2 is equal current, but it will pass through the Ocr2 where the setting is already set to sense the over current, so it will act and trip the circuit breaker. See how. Friends, now see how the earth fault relay works. I have told you it will follow its own circuit, this 27 kV side. Its earth is at solidly at the one leg of the power transformer. So through this it will complete its circuit. The phase is in OHE and return path, the neutral is connected with the one leg of transformer power, that is earth. So it will follow its own circuit if there is any earth fault. Let's see how. But this earth fault must be in power transformer 25 kV side winding to the CT. Outside it will not act. Okay. So it is called restricted earth fault relay. It will act from power transformer 25 kV side winding to the CT. This is the system. Let's see how it works. Friends, then we have seen that due to earth fault, the current has divided in two parts. One is returning from the earth fault point through earth to the power transformer 25 kV earth parts, and another is returning through the two CTs, CT1 and CT2. So when this will happen, the CT current will also follow two ways. One will pass through Ocr2 only, and another will pass, earth fault current will pass through Ocr2 and Efr2. So if Efr2 setting, that is 10% of the CT secondary current, it reaches or exceeds, then the Efr2 relay will energize and trip both the circuit breaker of the power transformer. See how. So the question is, Why earthfall relay trip? Why ocean will not trip when there is earthfall? The question is the setting of the earthfall relay is very low. That is 10% of the rated load current. When it will reach, it will trip the automatically the two circuit breaker. So there is no scope to trip the Ocr2 because it is a very little current during earth fault and it will trip immediately. So friends, this is the system. So I think you have understood, and this system is programmed in the microprocessor numerical relay. Simply we will take this 2CT secondary output and connect it into the relay for self-powered or some outside 110 volt DC we are giving to the DC supply we are giving to the relay for its power, and so many contacts are there, so many settings. So it is the basic idea. We are not the manufacturer, so we cannot tell the details. But this is the basic idea, and railway people, if you can understand it, that is sufficient because we are not manufacturing the relay. Simply you are monitoring and supervising. Thanks, friend. Have a good day. Today up to this. Next I will show you the transformer relay protection relays working. Okay. Thank you. Goodbye.